So we're digging into piecewise functions a little bit more here. And what I want to go over is how you write them, right? Like how you literally write a piecewise function. And we use this notation here with the giant squiggly bracket. And what that means is it's not just one thing. Okay, this equation that we're normally used to writing, f of x equals something, well, now it's equal to a bunch of things. And you can see that in the graph, right? We've got a bunch of things here. So let's talk about the one on the left because I think that's much more straightforward, and then we'll talk about the one on the right. So on the left, where does this function equal -1? Okay, the y value. Remember, f of x, that's y value. So I see a point right here. And what are the x locations where that is true? Well, it's, if you're thinking in interval notation, that would be -5 through -2 inclusive, okay, because it has closed dots. But that's not really how it wants you to enter the answer. Although I would know what you're talking about. The computer wants you to say something like this. X is greater than or equal to -5 and less than or equal to -2. These are basically saying the same idea, these two ways of writing it. But for one reason or another, when we write with piecewise functions, we typically use inequalities for the x values, or these conditional statements here. Okay, and now you can go through the rest of these pretty quick. -5, that's where x is greater than -2, but less than or equal to 1. And if you're wondering where I'm getting these greater than equal to's versus just greater thans, that has to do with these dots, whether they're open or closed. Open is greater than, closed is greater than or less than, or, you have that equal sign under it. I think I was mixing them up, but don't worry about that. Anyway, last one. Where is it equal to 1? That's going to be when x is greater than 1 and less than or equal to 6. Okay, so that's how you write those conditional statements. This kind of problem is pretty easy once you get used to it. The one on the right is going to take a little bit of imagination as we come up with the equations for these different portions of the piecewise function. So now it's telling you where to look, and it's asking you what the equation is at that place. So if I'm looking between -6 and -2, I can see that is pretty clear what this is. This is just y equals -3. Okay. The next one, I think, is actually the next easiest. It may be confusing at first, but what is this thing? I mean, take a look at that for a second. What is this? Okay, we go at 0, 0, then 1, 1, then 2, 4, then 3, 9. Okay, anyone remember this guy? Good old quadratic function. So this is just an x squared equation. And maybe yours looks like a different version of that. Maybe yours is upside down, but they're usually pretty easy to figure out. We don't throw any hard ones in this point. This is the challenge part of this problem, I think. And not that it's really that bad, you've learned this before, but how do we figure out the equation for a line if we know 2 points? Well, you need to know the slope, and with graphs, sometimes it's easier to just count. Remember what slope is, m. That's rise over run, so delta y over delta x. So I'm going up 3 and over 1, 2, 3. So this is a slope of 1, right? 3 over 3, which is just equal to 1. You could also notice, if you look at this diagonally, take a look, right? We go up and over one grid, up and over another one, up and over another one. So this is definitely a slope of 1 right here that we're dealing with. And now we have to make an equation for it. Y equals 1x, that's mx, plus b. So what you do to figure out an equation is you just plug in a point. Once you know the slope, you plug in a point. And I'm going to take this point right here because it's easy. Y equals 0, x equals 6. Let's figure out what b is. Okay, this should be easy to solve. You get -6 equals b. So you plug that into your equation, and you get y equals 1x plus b, or -6. So in other words, x minus 6 is the equation. That's the procedure you go through. When you're dealing with any kind of diagonal line, a linear function, first find the slope, and then once you're done finding the slope, find the y-intercept, this b value right there. Okay? And that's the method you'll use for these things.